Hello and welcome everyone. My name is Kelly here with Esri and I'd like to thank you for joining us on our webinar today. So today we're going to be discussing automated workflows and machine learning techniques for coastline extraction. And with that, I'll go ahead and turn it over to our first presenter today, Steve Snow.
Thank you, Kelly. Welcome to the 2021 Automated Workflows and Machine Learning Techniques webinar. Today's webinar is a continuation of last year's 2020 Maritime GeoAI webinar. You can find last year's webinar by using the link provided. First off, we're going to start with some quick introductions. We have myself, Madhu Husuru, and David Yu joining the webinar today. A little bit about myself. I'm an Esri Senior National Government Industry Strategy Specialist focusing on national mapping, charting, imagery, and remote sensing. I've been with Esri for about 15 years. I'm at the Esri headquarters in Redlands, California. And before that, I was a NOAA Corps officer focusing on remote sensing for aerial and hydrographic surveys for maritime charting and aviation charting. So Madhu, would you introduce yourself?
Sure, thank you, Steve. My name is Madhu Hosuru. I too work with Esri and I'm working for last 12 years and I located at Redlands. And I'm with ArcGIS Maritime team more than a decade and I was involving in all product development and releases through Pro and ArcGIS Maritime server. Back to you, Steve.
Great, thanks, Madhu. David, would you mind introducing yourself?
Sure. Hi, everyone. So David Yu, I'm a data scientist working on the GeoAI team here at Esri. I'm based out of Redlands, California, and I specialize in computer vision and deep learning, and I'm very happy to be part of the call.
Thank you, David. So today's agenda, what we'll be covering are some of the challenges for using GeoAI and charting. We'll be going over quicker production and the end-to-end AI lifecycle. We'll be discussing Esri's new capabilities with scaling enterprises with Kubernetes. Then we'll switch to Madhu, who will cover AI deep learning automation, focusing on satellite-derived shoreline and automating attribution. After that, we'll have a short Q&A. So, national mapping and charting organizations deal with rapidly changing environments. It often needs quick production turnaround. To do this requires that they leverage new production technologies such as deep learning and scaling their infrastructures to handle larger computes and delivering products faster. Some dynamic areas that currently require large amounts of manual production are areas along the national shoreline. The shoreline, according to NOAA National Geodetic Survey, is where critical data must be collected for charting territorial limits such as exclusive economic zones and for managing national coastal resources. There are many items that need to be collected in this rapidly changing area, such as artificial reefs, depths, obstruction, infrastructure. This often needs to be reported on a weekly basis for mariners. So many organizations also are working on leveraging new technologies into their modernization efforts. The integration of GIS and artificial intelligence is creating many opportunities for hydrographic, naval, and scientific organizations. Essentially, artificial intelligence is providing the ability of computers to perform tasks that were traditionally done either completely or partially by humans. Machine learning is a subset of AI that focuses on ingesting massive amounts of data for prediction, pattern analysis, and classification tasks. Deep learning is a machine learning technique which has been proven effective at imagery or video analysis leveraging deep neural networks. So in summary, GeoAI is equal to the machine learning plus deep learning, all within a GIS enterprise. So ArcGIS is an end-to-end geospatial AI system that supports an organization's AI lifecycle. AI works with all types of your organization data collection platforms. The lifecycle starts right from the time you access and collect the data, conduct data preparation for labeling, and with ArcGIS, users can start with pre-trained models or do their own training, as well as monitor, ensure proper quality assurance and validation, run their inferencing at multiple scales in production environments. And of course, being able to loop back to make decisions based on inferencing outcomes that solve an organization's real-world problems. So Esri provides what they call deep learning packages. Traditionally, time-consuming tasks such as manual feature detection are now being automated with the help of ready-to-use or pre-trained geospatial deep learning models. Esri has been developing support for deep learning in ArcGIS for a while now. Currently, there are 12 deep learning models available to download and use on the Living Atlas, with more pre-trained models on the way. We'll be talking a little bit more about this later on, and we'd actually like to get some input from the users here on what models they would like to see developed. Okay, so one national mapping organization that's having great success with ArcGIS and deep learning is the Kuwait Authority for Civil Information, or PASI. They're now utilizing ArcGIS for automating imagery feature collection across the country. The challenge the country faced was to quickly capture and deliver content through their GIS app called the Kuwait Finder, which is used by over 650,000 citizens every day. In order to streamline the capture of geospatial features, PASI turned to ArcGIS and GeoAI. The GeoAI and machine learning used satellite imagery. They built the models that help capture and maintain their databases utilizing ArcGIS automation, which of course reduced costs and saved time. Essentially, PASI took a process which used to take a 5-person workload 74 days to complete, down to just 1.5 hours processing time with 2 days of QA and QC. They're really realizing the benefits of automation with ArcGIS. Okay, now I'm going to switch gears here. So if you have to deal with very large or extremely quick deployments of AI, you can now utilize something like cloud deployment with Kubernetes. This is a new deployment pattern that's available this month. It's brand new. So I'm going to just go over some of the basics here. So there are many patterns of cloud usage by hydrographic offices and national mapping organizations. There's infrastructure as a service. Think of ArcGIS Enterprise on Amazon Web. Platform as a service using ArcGIS Location. Software as a service. Think of ArcGIS Online or ArcGIS Velocity. So these are all supported currently. But to understand what Kubernetes does, we have to take a look at how cloud native has evolved. In traditional deployments, as you see here, organizations ran large applications on physical servers in their organization. In this deployment, resource boundaries were often poorly defined. So if multiple applications were run, one application might use up most of the hardware resources. Scaling through this approach was very difficult, mainly due to inefficiency in resources. The next evolution was with virtualized deployments. Virtualization allows you to run multiple virtual machines on a single physical server CPU. Applications can be isolated between the virtual machines. This isolation provides security between applications And also virtualization allows better use of physical resources and provides better scalability than the traditional deployment, as well as reducing hardware costs. So the next evolution was the introduction of container deployments. Container deployments are a step beyond virtualization, where the operating system can be shared by the applications. In some aspects, containers have similarities to VMs, with the exception that the components of a containerized operating system are portable or created and destroyed across a cloud or multiple clouds. Now with ArcGIS Enterprise and Kubernetes, we can deploy on Windows and Linux environments as cloud native. So just real quick, if you're unfamiliar with what Kubernetes is an open source orchestrator for managing and deploying containerized applications at scale. It was originally created by Google. So software essentially can now be delivered as microservices in which an application is a collection of loosely coupled services. The approach to using microservices is new and used to easily scale and develop on. Kubernetes is used to manage the life cycle of the containers, allowing easy creation and destruction of them as well. And just a useful fact here, Kubernetes is usually referred to as K8. So you might ask, well, what are some of the benefits of this new deployment pattern? Well, it makes deployments easier. Cloud native is easier and utilizes more efficient use of containers images versus virtual machine images. It provides reliable image builds, deployments, and quick rollbacks. You can observe not only the health of the operating system, but also the applications you're deploying as well. It's very portable. It's loosely coupled, which means microservices are broken into smaller independent pieces and can be deployed and managed dynamically. Think of this not as a huge program on a single machine. So, and a little bit about ArcGIS Enterprise. ArcGIS Enterprise is the foundational system for your mapping and visualization, data management, spatial analysis, and application building. It's essentially the backbone for your GIS workflows. It's designed to integrate with ArcGIS Pro, ArcGIS Online, ArcGIS Velocity, and all of Esri's suite of application. ArcGIS Enterprise is installed on infrastructure you control, whether it's in the cloud or on-premise, and can be scalable to meet your needs. ArcGIS Enterprise enables administrative roles in the organization where GIS and IT can work better together. These roles can help the IT manager and GIS analyst quickly respond and ensure continuity of the system's operations. With Kubernetes, upgrades to the system can be scheduled, downtime can be reduced, and your system health can be monitored, as well as further automation implemented. This means that the hydrographic organization has more deployment options now and can scale with a broader hydrospatial community. So you have your traditional deployments as well as this new capability for deploying as cloud native. So it's kind of an exciting time. So Kelly, we have our first poll. Would you mind launching the poll? So the question here is, and I'm hoping the audience can participate, how familiar are you with Kubernetes? We're really curious. This is brand new. So let's take a look at the results. So as you can see, we've got 80% are fairly new at learning about Kubernetes. And then we do have about 20% of the audience that is familiar and has some experience with Kubernetes. Thank you, Kelly. Okay, great. Kelly, would you mind running the next two poll questions? Thanks. So it says, from the implementation for ArcGIS Enterprise, which environment would you be inclined to implement in your organization? Okay, Kelly, it looks like we have the majority of the answers in. Would you mind closing this and showing the results? Well, great. It looks like the majority of the organizations would be deploying this on their own hardware on premise. With the second is going to be a combination with virtual machines and containers in the cloud. Great. Thank you. Let's go ahead and run the next poll, and this is going to feed into Madhu's presentation. So we mentioned a little bit about AI, pre-trained AIs for the audience. So last year we did the shipwreck finder. That's all available for the audience to use if they need to run through bathymetry, do object detection. What we're interested in finding out is what, and now we've done shoreline, which Madhu is going to be covering. What would be the next one? We're curious what the audience would like to see on their Christmas wish list for a pre-trained AI, maybe. It's not a promise, but we're really interested in looking at what would be the most useful with our limited resources. Okay, Kelly, it looks like we have the majority of the audience voting on what their favorite AI would be for 2022. So you want to share those results? Great. It looks like by far the largest pre-trained AI would deal with hydrographic surveys, depths and channels, followed by mariner reports of suspected shoals. And then in third place is dump sites, submerged pipelines, and cables. Great. We really appreciate this feedback. So this gives us some great discussions. And we will have a Q&A at the end. So please utilize that if you can in the questions block there. So Madhu, I think we had some great responses from the audience. Would you mind starting with your presentation?
Sure, Steve. Hello, everyone. Welcome to coastline extraction using automated workflows and coastline classification using machine learning techniques webinar presentation. And this presentation will have two parts. The first part covering the coastline extraction using automated workflow, followed by a quick demo. Then I'll take into the coastline classification using machine learning techniques methodology. Then after that, a quick demo about those workflows. And my name is Madhu Hosuru. I work with ArcGIS Maritime team. And I would like to take you guys to the first part of this presentation, that is coastline extraction methodology. These automated workflows developed using ArcPy, using Python. And the components of this automated workflow are, the first component is input parameters. User needs to provide the area of interest where they want to extract the coastline, along with the source of image server and the date range from to date, so that they can extract the coastline for coastline change analysis or coastline boundary analysis, or for any particular event happened before and after the event, how the coastline got changed using latest imagery from image server. And the second component is raster tools. So basically, this extraction methodology is mainly using a band ratio technique to generate a normalized difference water index. Using that, the main component of this extraction, using this generated NDWI, we are doing further analysis and generalization tools from ArcGIS Pro, example clip, smoothline, buffer tools, and also a few other tools like polygon to line, generate raster from raster function. And these analysis, generalization, conversion, and data management tools are using in this automated workflow as they needed. Even though I listed at the step as third and fourth, those are not coming in the sequence, but they come in as they needed in the process of extracting the coastline. Let's take a look at input parameters. The first one is area of interest. User needs to provide the polygon layer. Then the second one is the image server as a source. In my case study, I'm using Sentinel-2, and you may need to provide a login credentials to use this. Then the third parameter is cloud coverage. And the percentage of cloud coverage in my case study is less than 3%. And another important parameter is imagery date range from minimum to maximum. So with all these input parameters, the coastline extraction geoprocessing tool looks as displayed here. And here another parameter is output raster folder location, where the script is going to use to store intermediate outputs and the final output. And with providing all these valid input, run the tool, and I would like to take you guys to a quick video here as showing here with these three, all these parameters, when we run this coastline extraction, so on the fly it is downloading the tiles from the Sentinel-2 and creating the CRF file and adding a custom metadata fields and applying the band ratio technique, and all steps within less than 2 minutes is done for a provided area of interest. So I would like to take you guys to step by step more detailedly and see how accurately this automated workflow is extracting the coastline. In this process, using analysis and raster tools, the first step is create a AOI buffer. As user provides the area of interest, the tool creates the buffer for that area of interest. In my case study, 500 meters I used as a buffer radius, which will help us to extract coastline and align the final extracted coastline with any existing coastlines. And the second step is filter out the Sentinel-2 tiles and create a cloud raster format .crf file. Basically, this file contains multi-dimensional raster data, is divided into small bundles of tiles, which allows multiple processes to write simultaneously to an output. And generating the NDWA raster by applying the band ratio technique. This is the formula is NIR minus blue divided by NIR plus blue. This is the formula we applied from the downloaded Sentinel-2 tiles to get the NDWA raster. And using a blue band, we observed a better result. So we stick to that formula in my case study. And to use this raster calculator function, we need a image or spatial analyst extension. Once we had NDWA raster, then we are going to reclassify. So as displayed here, the values are reclassified 0 for the land and 1 for the water using reclassifier. And to do this step, we need a 3D analyst or spatial analyst extension. Once we get the reclassified raster, we are applying the majority filter to each pixel to remove the noise. So basically, before applying that, we need to manually verify that this really noise or it's required data to keep for further extraction of the coastline. So as illustrated here, this process will replace cells in a raster based on the majority of their contiguous neighboring cells. And to use this majority filter tool, the spatial analyst extension is required. After applying the majority filter, convert water and land polygons using a raster to polygon tool. So as displayed here, the illustration of this converts a raster data set to polygon features. Then in the next automated steps workflow, we are applying analysis and generalization and conversion tools. And to do that, we selected the largest water polygon area, then convert water polygon areas to a line feature using a polygon to line. Basically creates a feature class containing the lines that are converted from the polygon boundaries as illustrated here. After getting a line features, apply a smooth line tool on it with the tolerance. In my case study, I use the 30 meter as a tolerance so that to remove any sharp angles in the line, also add more vertices to the smooth line, which will help the user at the time of manual QC. If they want to tweak any minute changes, the more vertices will help them to do that more accurately. Then using user input AOI, clip out the extra lines. And the next step is add custom metadata fields as like source from where we are extracting the coastline, and also the scale of the extracted coastline by applying the formula raster resolution multiplied by 2 multiplied by 1000, and the article related to this is available to take a look. Then finally append the final coastline shapefile as a coastline feature class. So all these steps will be done very quickly based on your area of interest using this automated workflow. And also I would like to give you additional information, the story map and the sample book available to take a look on Landsat 8 as a imagery server source. So go to the story map to see the methodology, how to use Landsat 8, as the Landsat 8 and the Sentinel-2 have a different band structure within it. So that's the reason we need to use little bit different combinations to get the extracted coastline. Then the sample notebook also available here. And I think Steve is posting a links in chat.
I've been posting the links, Madhu, there in the chat for anybody that wants to have these links live to follow along. Thanks,
Sure,
Madhu.
thank you, Steve. And the conclusion of this methodology as displayed here, and the literature and resources referred also as displayed here for this case study. And with this, I would like to take you guys to the quick demo. Okay, let me open the coastline extraction geoprocessing tool. I'm not running the tool again due to the time constraint limits. So basically, the output of this tool is with the user provided demo AOI in the Florida area. The first step is the AOI buffer. Let me turn off the Sentinel-2. So once we get the area buffer, we downloaded the tiles from the Sentinel-2. And these are the all 12 bands data for those area of interest. And applying the band ratio technique, generated NTWA raster. And these are the raster values. And reclassified that into 0 and 1. That is 0 is land and 1 is water. Then applied a majority filter. If you see a few areas here, by applying a majority filter, that noise got removed, and we applied twice to remove further noise. If you see a few areas here, so just I want to show that this majority filter can use based on your requirements. Then water and polygon feature got generated here. Then out of that selected largest water polygon. Then this is the coastline got generated. Then we smooth the generated coastline to have a more vortices. Then finally a shape file with exactly within the area of user provided polygon. So let me turn on these two and turn on Sentinel-2. So the extracted coastline looks at displayed here. This, let me take you guys back to my slide deck. So we are done with the demo, and I would like to give a few limitations of this coastline extraction methodology, and we are looking into it, a few of them. The first one is if the image server has the image with the water splash on rocks at the coastline, sometimes we observe a false positive predictions, and we are looking into this limitation to enhance and resolve this problem. And the second limitation is the tool will result in an error if the selected date range do not have any data within the source imagery server. So basically we provided dates between if some bands do not have a data, the tool will result into error. Then in that case, we need to change the right combination of the data to get the extracted coastline successfully. And the third one is the extracted coastline will append as a single line right now. We are in the process of enhancing to update as a multi-line. And another limitation is we are looking into find how to add a datum component of the coastline extraction. As now we extracted the coastline, now I want to give a demo before. Demo will be later. I want to walk through the methodology, how we are going to classify the extracted coastline using machine learning techniques. The components of this machine learning techniques using the ArcGIS API for Python are going to be displaying here. The first one is the prepare training data. So for this step, we are using export training data tool, and this tool requires image or spatial analyst extension. And the second component is training a model based on the exported training data. Here we are using a feature classifier models, and this step requires image analyst extension. And the lastly, the use the model or inference the to get the classification using a trained model, that is using classify objects tool, and this tool requires image analyst too. So let me take you guys a little bit more details about these steps. The first step is important step preparing the training data. Here I am using export training data for deep learning geoprocessing tool, and this tool required a few input parameters. The first one is input raster. As earlier I mentioned, I'm using Sentinel-2 as the input raster for this case study, and we need to provide the output folder to save the exported training data. Then the input feature class. This is the one of the important parameter. In this case, I created a shapefile with a polygon intersecting the coastline category imagery. For example, like I created a one shapefile for the marshy shore category on the Sentinel-2 imagery, manually visualizing and created a line, and I created a one shapefile for that. So like that, we need to create a different input feature classes for different categories of coastline manually visualizing, or the area where you want to get a more accurate training data. And the tile size I used 256 by 256, and the image format is a TIFF, and the stride values are 128 by 128. Basically, the stride is the distance to move in the X or Y direction when creating the next image chips. When the stride is equal to tile size, there will be no overlap. When the stride is equal to half of the tile size, there will be 50% overlap. And in my case study, I used a 50% overlap to not to miss any area, and I want to train my model in a more efficient way. And another field is a metadata format. I choose label tiles where each output tile will be labeled with a specific class, which we are going to use at the time of training and training a model, and later the model will utilize that to classify the coastline. And finally, the cell size value. So this value depends based on the input raster, as the map resolution of the Sentinel-2 is 10 meters. So I provided the cell size as 10. So based on your input, we need to change the value of this cell size. With all these inputs, the export training data for deep learning geoprocessing tool looks as displayed here. So I provided all the input and the output folder location, and also on a few other parameters is the extent, like intersection of the inputs. Basically, input feature class intersecting the Sentinel-2, it goes and export the chips, basically images, and the exported images, few sample are as displayed here. And basically, we need to repeat and export training data for each different category of coastline values. And also, if you want to export the training data on a different input raster like Landsat 8, we need to repeat this process so that we can use all exported different input raster data at the time of training a model, so that the model can be used to classify a different input raster later point of the time once we extract any coastline using automated workflows. And I would like to give a quick demo here. And export training data for deep learning tool displayed as here, and input raster and output folder. Also, I've provided the tile size X and Y along with the labeled tiles and other parameters. Once you run this tool, we get exported chips in a location what we choose. So and these are the exported chips. This I would like to take you guys to the next step in the machine learning techniques, that is training a model. I used a Python notebook, and we need to import the necessary modules, and the important one is the feature classifier. This is the module we are using to train a model. And in my case study, I used the ArcGIS version as a 1.8.5, which is the latest for ArcGIS API for Python version. And prepare training data and visualize. So from our previous step, the exported chips, we need to locate them and basically just run this data.show to make sure we are running on the right data. Basically, we are using the right data to train a model. And the next steps as displayed here, those are going to use to train a model through learning rate tuning and transfer learning. So these steps can be repeatedly executed based on the satisfaction of your learning rate value. So later point of the demo, I'll take you to the Python notebook where we can see more details about this. And the last step in this Python notebook is visualize classification results in validation sets. These are the commands to do that. And once you are okay with the ground truth and prediction values from the model.load, then you can save that model and start using in the classification, that is, which is in the next step. And before that, I would like to give a little bit more details about the confusion matrix. The diagonal values represent the number of points for which the predicted label is equal to the actual label. The greater the diagonal values of the confusion matrix, the better, indicating many correct predictions. So if you see here, like for the class 1 to 1, we got 186 points. But if you see the class 2, we got only 1. So this is the indication that maybe you need to export few more images for the class 2 and rerun this model. So I purposefully kept this for this demo. So based on this confusion matrix values, we can determine to do one more round or a few more rounds based on our satisfaction to train a model, which is going to be playing a major role in the classification of the coastline. And the final step is use the model inference. But before that, we need to do a quick data preparation to classify objects using deep learning. Whereas to inference, we need to provide the polygon input feature class, which identifies each location that follows the extracted coastlines to be classified and labeled. So this is the one of the important step for this. So if you see the image here, the extracted coastline needs to have a rectangles following that, and which will help us to classify each rectangle area. We can label them what type of or what is the classification of that coastline. So, and to do this, to create a series of rectangles, polygons that follows a coastline, it is not a manual process, and we have a tool called generate a rectangle along the lines. And here you can provide a meters value on what is the rectangle size of which is going to follow the line. So you can provide that, and using generate rectangle along the lines will generate as a rectangles very quickly. Before using this tool, we tried with the create fishnet tool, and with this we are getting a bunch of rectangles outside of this extracted coastline, and which causing the classification tool taking more time, and it's not required for our purpose. So that's the reason we stick to the tool called generate rectangles along the lines. And the final step is classify objects using a deep learning tool. This tool required input raster, and the input features from our previous rectangles we created along the coastline, and the output feature class we need to provide where it is going to store all the classifications, and the model definition for this parameter we need to provide the trained model from our step 2, and along with the other values. And the another important I would like to mention, processor type is the GPU I selected, which will get more like it's based on the hardware configuration. It will be fast enough to classify. And the output of this tool is the class label is 8, that is marshy shore, and the confidence values are 0.99, which is close to 1. That is the indication that classify objects using deep learning tool detected are classified coastline in a better way. And the 8 is the marshy shore category of the coastline. And with this, I would like to take you guys for a quick demo. I think before that, I would like to give a quick glance on the automated script. Earlier, I didn't do that. So if you see, these are the like few lines where we are doing the band ratio technique, and we are applying the reclassifying parameter values and using majority filter, all those within the Python script. So with that, let me take you guys to the quick demo of the machine learning techniques. The first tool is export to training data for deep learning with all these parameters. The output looks as displayed, and we are going to get the images in TIFF format. And if you see the screen here, I exported the sample images both on Sentinel and also World Imagery, so that my trained model can be classified any of these two input raster. And after exporting the training a model, this is the notebook and the imported modules, and I pointed to the prepared data, all the locations what I exported, and if any mistakes happens, we get the error when we run this step. That is a useful error we need to go and fix. I purposefully added this error, and here the data that shows the images, and we can confirm that we are running training a model on the right data. And I used like 9 classes for this training a model, and this is my learning rate, and model dot fit with the 40 epochs, and the ground truth and prediction as displayed here. And I saved this model, and this is the location. So the once we save the model, we get the saved model file structure are displayed here, and this is the confusion matrix details. So then after that, generate rectangle polygon lines is the tool where we need to generate rectangles, which will help us to pass that to the next step. So as displayed here, the generated rectangles looks here. Then the next one is the classify objects using a deep learning tool, and the output of this tool is classified. And if you open the attribute table of this, we can see class label and confidence value for the classified objects. So with this, let me take you back to my slide deck. And also, I would like to give a quick update on the demo application available on Esri Hydrographic Office. And as Steve mentioned earlier, last year we have a webinar and demo app also deployed here, GeoAI Shipwrecks. Basically, last year we had a webinar on this topic to detect shipwreck on the survey data using Esri machine learning techniques. I encourage you guys to take a look out about this application, and also the YouTube link what Steve posted, so that we can see the end-to-end workflow there. Based on the user's input, we have an enhancement on this process. Before, we used to find the centroid of extracted polygon from the machine learning's output, and we are pointing that as a shipwreck. Instead of that, we enhanced this tool to find the shallowest point of a detected shipwrecks polygon, then place there as a shipwrecks, which will help us. So that's the updates we have here, and we are going to very soon updating that script in Maritime Esri community page. And also you can see other demo applications, products on demand, custom charts, and maritime chart service and ENCs. These are the ArcGIS maritime server capabilities, and the last one is bathymetry server capabilities.
Madhu. So I have posted those all on the chat for everyone, all the demos that you said, and also it might be just worth mentioning that I believe the shipwreck trained AI is available on that Living Atlas page as well. Isn't that right? True?
That's correct. And I think you posted those links, right? Yeah, thank you for that. Ready to use model is there, and also user guide how to use, and also sample data. So please play with it and give us a feedback, and also look for the Maritime Esri community page for the announcement from the ArcGIS Maritime team. And also let us know by sending an email for any questions or ideas you have. So back to you, Steve.
Okay, great, Madhu. So we have about 10 minutes now for question and answers. I'm going to go ahead and let's see, pop out the questions here. And David, you're on the line too, correct?
Yes, that's right.
Okay, great. Let's start going down the list. We've got quite a few questions, but we do have time. If you'd like to enter some questions in from the presentation, just there's a question box there that, let's see. Okay, first question. I guess this one's for Kelly. Kelly, will the recording and the PowerPoint presentation be available after this webinar?
Yes, Steve, thank you for asking. The recording will be made available. We should be emailing out that link within the next couple days. And then any of the resource links you see here in our presentation, we will make those available as well. So if you missed them in the chat or don't have time to type them in and save them, we will make sure that those get added for you.
Okay, this next question is for both David and Madhu. What is the software required for using the machine learning tools in ArcGIS? For example, ArcPy, TensorFlow, Keras, etc. Can both of you comment?
Sure. So first of all, in order to run some of the deep learning tools that you've seen in the demo today, you need to install the various dependencies and libraries. And I will post a link shortly into the chat on where you can find and download those dependencies. In terms of the extensions, then it would be image analyst is a big one, right? So in order to run some of the tools like export training data and also train deep learning model, you need to have the image analyst extension. And Madhu, would you like to add to that?
Yeah, that's good information, David. And also to do other basic steps, ArcGIS Pro is there to help us. So along with the 3D analyst as automated workflow. So the combination of those, as David mentioned, the package installed and also the Pro will help us to do these techniques.
Okay, great. Next question. Was the Sentinel-2 download resampled due to area being investigated? It looks more coarse than the source resolution. I guess that's you, Madhu.
Yeah, yes, we did, but again, this once you run this automation process, we need to add a manual QC steps. So yes, they required a manual verification and inspection. Then only we need to push to the next level.
Okay, great. Next question. The map I am interested in is seabed topography from the shoreline to 5 miles out, covering details like wrecks from a sample area like Martha's Vineyard, Massachusetts, or the Isles of Scilly, UK. Is data available to cover something like this, where it can be converted to a 3D model representation? Madhu, maybe?
Yes, we can do, but I never played with multiple data here. Yes, we can. I think it is possible, but how I need to play and get back to the user. So maybe if they email us, maybe we'll touch with and we find more requirements there.
Okay, so if you can email maritime@esri.com, we'll try to follow up after this webinar. It sounds like a pretty complex project. Okay, next question. This is for you as well, Madhu. What is the band combination at the, I'm having trouble reading that, maple image Do you know what that is, Madhu? Oh, sample. Okay, it's a typo.
Sorry, can you repeat the question?
The question is, what is the band combination at the sample image?
Yeah, but as earlier mentioned, the band ratio formula, like we are mainly focusing on NIR and blue bands in this extracting the coastline. So that's the formula. I think they can go back to our video, and I provided that formula. So that's the combination. But to get a raster, we need even band red. So that's the reason we use 3 of them.
Okay, great.
Yeah.
Okay, next question. This is more of seems to be a turbidity question. It says, I primarily study the coastline of Lake Ontario. Can this model deal with high sediment situations? What do you think, Madhu?
Oh yeah, that's interesting idea of applying this. So I'm happy to apply and work with that user. So yeah, please again send us an email with maritime@esri.com. We can engage with that user to do that work.
Yes, yes. So this can be tried out in more environments, right?
Yeah.
Okay, perfect. Okay, so here's another one, and this one is, what is coastline defined as in this workflow? Since the watermark is used at the shoreline boundary, does this model account for intertidal variation? We knew this one was coming up, right, Madhu?
Yeah, yes.
So would you mind talking a little bit about how we might deal with imagery and tidal variation?
Yeah, actually, for that again, like we straight away, like this extraction, we not added like major components what we need to update chart, nautical chart. That's the first statement I want to give. This is the only 2 metadata fields added, that is the source and the scale value, and all other fields we are in the process of doing further research and enhancing this tool, Steve. So I would like to add that that user's contact, so that we can touch base and see what exactly they want to do from this extraction and how we can do it.
Perfect. Yes, it's good to mention that usually Esri and hydrographic agencies can work together on projects if this is something that further development could be done. You know, Esri has partnered with organizations in these matters. So, and it's similar to, we've got this very similar question from Indonesia here. Same answer. So we just need to work with these organizations and better data, of course. You worked with what you had, right?
Yep.
Yeah, perfect. I'll just, and for the person in Indonesia, if we don't get back to you, please shoot us an email at maritime@esri.com. Thank you. Okay. The next question, I guess they're asking, can you discuss iteration on the AI models a little bit, maybe, David? You know, what does that mean?
Sure. Generally, when you train a machine learning model, you are not passing all of the image chips into the model in one go, right? You're essentially batching them together, and the number that goes into a batch would also depend on the GPU memory that you have. So for instance, if you have a fairly beefy GPU, you can afford to have more items or more imagery in that batch. And then you're feeding them through in iterations, right? So your entire data set can be divided into, well, let's say, for argument's sake, 200 iterations. And then by the time you consume those 200 iterations, that's essentially one epoch in the training time. So when you actually start training that model, you will see in the output messages, basically the corresponding accuracy values associated with every epoch, right? So that's basically after all the iterations have gone through the model, here's the output. So that's basically what iteration is. And generally, what we expect to see from these types of models is as the number of iterations increase over time, the model starts to perform better on the training set because the model has essentially started to learn, what are the salient features to pick up in order to make that classification or detection. And also a good rule of thumb is to also keep an eye out on the validation accuracy. So when you actually train your model, you will see as iterations increase, the training accuracy will also obviously increase, but at some point the validation accuracy would start to decrease as your model starts to overfit. So that's probably where you want to stop training and begin inferencing on your model.
Okay, great. Thanks, David. Okay, Madhu, quick question. Can we change the automated script based on our own hydrographic requirements?
Yes, the script can, other than the on the UI parameters, the main components like cloud coverage and reclassifying parameter values, majority filter, different mechanisms. So all those are can be customized within the script, and you are ready to run without any further development required.
Good to know. Thank you, Madhu. Okay. And this is another one for you, Madhu. What precision of coastline extraction can we expect with the Landsat 8 imagery?
Yeah, that's a good question. So that again depends on the area of interest where the user provided. So we observed some busy area with many features. There we got a little bit less accuracy, but whereas simple area we got more accuracy. So with that, I think around 70 to 80% I can say. As per my samples, I'm not sure all the entire US I didn't run, but whatever the samples I took, I can say that 70 to 80%.
Okay, perfect. Okay, so this is another one. I'll take this one. This question is, where can we find support with Kubernetes configurations for ArcGIS server? Esri has support pages and new documentation coming out, and I will follow that up with an email. Okay. So the next question, Madhu, is for you. It's does the scripts work also with high resolution images than the Sentinel-2 imagery, for example, worldview? Can it work with others?
Yeah, basically the source should have a band ratio technique to apply that formula. So that's the idea. So if you have that similar, yes, it will work.
Okay, perfect. Here's a really good question, I think, for both of you. What is the smallest type of object you would realistically try to identify within a data set? In terms of shipwrecks, is there a max/min size before it becomes too much for most hardware? That might be a David question.
Sure. So there's two things that would determine the smallest object that we could pick up. One is obviously the resolution of your image. If you want to start detecting things that are super, super tiny, you want to make sure that in both the training and testing sets, you have access to high resolution imagery. The other consideration is if someone manually goes in and tries to identify that object, can that person detect that object within, let's say, less than a second, right? And that's usually a good rule of thumb, and that if a person is able to manually identify that object, then odds are the machine learning model, once it's trained, would also be able to do that.
Okay, great. Well, that was our last question, and we're about 8 minutes over time. I apologize about that. But we're going to head and close this out now. We'll try to follow up with all the questions. Recordings will be available afterwards. So Kelly, would you mind closing out the session for everyone?
Yeah, sure thing. Thank you, Steve, and thank you, Madhu and David, for the wonderful presentations and demos and for helping getting those questions answered. As mentioned earlier, we will be recording, or this has been recorded, and we will be posting the link to the recording location, plus any of the additional resource links you saw here in the presentation later on, and everyone will be receiving an email with that location within the next couple of days. So again, thank you so much for joining us. We really appreciate it. Thank you so much for participating in the polls and all the questions, and have a wonderful rest of your day.